Yes, this. Oh my goodness, it's a review video. Whoa, what do we have here? Oh my goodness.
It's a shark.
Oh my goodness, what's. Whoa, what happened? Oh, I don't know if I can help you with that. Oh my goodness.
I mean, I've heard sharks don't sleep, but there's a lot of controversy about that.
Oh wow, really? Yeah. Wow, that's rough, my friend. Yeah, and well, I don't know. Yeah, we might. Yeah, we might be able to help you out.
Never heard of a shark that's scared.
Very strange. Okay, you're a really cool guy, but yeah, well, my fourth graders are kind of waiting for a video here. So you know what? Maybe we can, chat later.
Off the record,
We'll we'll see what happens. And you are kind of.
freaky looking.
I'm sorry, I said that out loud. Oops, sorry. No offense. Okay, let's get serious, guys. Okay, yeah, sorry. I kind of shrunk you down, get you fit in there so that way we can do our math, okay? But you can stay there. Don't worry, okay? We're not going to hurt you. Okay, look at those teeth. Anyway, chapter 1 review, my friends. It's time to get serious. Mr. Ward always claims that he's here to do math, but let's face it, he jokes around. Like I mentioned in an earlier video, I've been teaching fifth grade for a lot of years, and typically how I do these review videos is I basically make 3 videos, and there's like 2 pages for each video. So you'll see like a chapter review 1, 2, and 3, and it'll include the 6 pages that comes with the review. Anyway, this is a great way to study for a test. If you have a teacher that uses the actual test for the Go Math, these review tests are great. I did them with my students. It kind of helped them prepare for the test. They're almost identical. They just use different numbers. All right, but I'm going to explain my thinking. I'm not just going to give you the answers, okay? I'm talking through the problem so it helps you understand the math, okay? Cool. Well, let's get started here. First one says select a number for, and then you can see the gray square there, that will make a true comparison. Okay, so we need to find numbers that are going to be less than that 703,209. In the instructions, it does say mark all that apply. And whenever they put mark all that apply, you know what that means, right? Yes, that means that, yeah, there could be more than one correct answer. So we have to really be careful. I think the strategy I would probably use in this problem is to simply, just take a look at the place value here. The 100,000th place is a 7. The answer choices are all 6-digit numbers. As you can see, they all have a 7. We're just going to keep moving to the right. Now in the next place, we have a 0. And it appears that not all of these have a 0 in the second place. In fact, if you look at this number here, they're switching them around. Okay, we have 730,000 twice here. And so that makes the number larger. That digit 3 in the 10,000th place makes those 2 numbers larger. And so these can't be answer choices. We've already eliminated those. Now we just keep moving over. We still have 703. This one here, 702, is definitely one of the correct choices here because it has a 2 in the next place value. So that 2 is less than the 3. Therefore, that number will be less than 703,209. Now comes the ones period here. We're going to look at those digits. Here, this is just like a regular number, then you'd be able to do the rest, right? If you have 29, is 29 right here less than 209? Sure. Okay, and the 0 there lets you know that it's less than right away, right? The 0. So that's definitely a possibility. Look at the 209. Oh, these numbers are identical. Can't be that one. Okay, these are out. This is out. And now over here we have 290. Well, that 9 in the tens place, see where we have a 0, that's a problem. That makes that number larger. Okay, not by a lot, but it makes it larger. So the only answer choices we should be choosing here in this problem is A and B. Cool. All right, let's keep moving down. See you later, Sharky dude. Yeah. Okay, it says Nancy wrote the greatest number that can be made using each of these digits exactly once. What was Nancy's number? How do you know this is the greatest possible number for these digits? Well, great question. Well, we have 6 digits here. So I could almost think of this, if this were the number. Now, would this be the greatest number? Well, it would not, because the greatest number would need to have the largest digit in this place here of the 100,000th place. and we have a 5 there. But 9 is greater than 5, 8 is greater than 5. So what we'd want to do, and I can see the strategy I would be using, since the greatest place value is furthest to the left, then I would be putting the larger digits to the left and the smaller digits over here, like here with the ones place. In fact, that 1 could stay right there. Okay, so I would put in my 9, then take the next largest one, 8. This is the strategy I would use. 8, there's no 7, 6, but there's a 5, there's a 4, there's a 3, and then we already said the 1. So that would be the number that I would have. So let me go ahead and answer this question. So her number had to be, I wrote it up there, but I'll put it here in the box, 985,431. And then I need to explain, how do you know this is the greatest possible for? Well, because how place value works. I started by placing the larger digits furthest to the left, because I know that each place value to the left is 10 times greater than the place value to the right. Meaning, let me just show you up here. So like the 1, I know that the 3, that place value is 10 times greater than the ones place, and I know that the hundreds is 10 times greater than the tens, and the thousands are 10 times greater. So that's the reason I started placing the greater digits furthest to the left, because each place value to the left is 10 times greater than to the right. There's obviously different ways that you can answer this question and still get credit. I typically, on these exams for my students, I tend to offer a lot of points. So this problem may have 4 points or 5 points, and I award those points based on how well they answer. So there's more than one way you could answer this, and I'm sure that your teacher is going to understand that what's important here is that you get the correct answer here, obviously too, but how do you know? Well, place value has rules. Let's move on. Now it says part B. It says, what is the least number that can be made using each digit exactly once? Explain why the value of the 4 is greater than the value of the 5. Okay, well first let's just go ahead and take a look at what would be the least. So our number up above, let me just rewrite it down here. Our number up above was 9, 8, 5, 4, 3, 1. So the least number means we're literally going to switch the number around, because if the 100,000th place is the greatest place value because it's 10 times greater than the 10,000, it happens to be 100 times greater when you compare it to the 1,000, and then it increases more than 10 times. It just means that, hey, if this is 10 times, then if you go 2 places over, it's going to be 100 times. If you go 3 places over, it's going to be 1,000 times. That's all that means. 10, 10, 10, 10. That's the secret. I would just rewrite the number then the opposite way, because I'd want the smaller digits in the locations of the higher place value, because I'm trying to make the least number. And then I have my 5, 8, 9. So this would be the least number using the digits exactly once. 134, 134,589. Now, to explain why the value of the 4 is greater than the value of the 5. That's a great question. Or not a question, but I have to explain. Well, it's pretty simple, because we just talked about it. The place value of the 4 and the place value of the 5. Well, the 4 is to the left of the 5. That means that that place value is 10 times greater. It happens to be, in that place value, it happens to be the thousands place. Okay? And the 5 happens to be in the hundreds place. You can see when you compare those two place values, this one is 10 times greater. So why is the 4 greater? Yeah, because it's in a higher place value. It's in a greater place value. It has a value of 4,000, where the 5 in this has a value of 500. I'm just going to say, make it simple. The 4 in the thousands place has a value of 4,000, whereas the 5 only has a value of 500. And I didn't write out even, that because it's in the hundreds place, but that's shown right there as well. Cool! Woohoo! Yeah! Now, that's one page down. Let's move on to the next page. Now it says U.S. mountain peaks. Oh, I love it. Woohoo! It's a table that shows 6 different peaks. And we have Blanca Peak, Crestone Peak, Humboldt Peak. Oh, they're all in Colorado. That's what the CO means. All over 14,000. Then we have We have Mount Whitney. We have University Peak in Arkansas, and White Mountain. Now, something interesting here. Not trying to toot my own horn here,
But yes, Mr. Ward, that's probably what you're going to do.
but anyway, I've actually hiked Mount Whitney. It is the tallest mountain, what they call in the 48 contiguous states, meaning the only one that's taller is Denali in Alaska, which they don't have listed here. But I just want to let you know that is not actually the correct amount anymore. And I've also hiked White Mountain as well. Very cool. Yes, I'm into hiking. I know, pretty wild, huh? Mount Whitney. It's 22 miles. And if you know anything about elevation gain, it's a good 7,000 feet gain that you have to actually hike. Anyway, just a little side note, just because I'm really into hiking. I actually hiked Mount Whitney on the 16th of July of 2018. So, pretty cool. Which right now, since I'm making this video, that was just a little while ago. Cool. All right.
Mr. Ward, can we get back to the problem now?
Oh, but of course, okay? But we have to use this number because that's what's in the problem. Okay, now it says write the name of each mountain peak in the box that describes its height in feet. So we have ones that says between 14,000 feet and 14,300 feet. It's like a range, okay? And here we have 14,301 feet and to 14,500 feet. You see, it's the lower end, kind of like the higher end. Well, the key thing that I'm looking at to make this problem really easy is this 3 right here. Because basically what we have is they're all going to be, you're going to have some that are either less than 300 feet. I'm assuming all of these, yeah, because all of these are at least 14,000 feet. All of these peaks are going to fit in one of these two boxes. But what's key here, if you go to the ones place, this has a 0, this has a 1. So all we really need to do is just kind of look carefully at the hundreds column. In the hundreds place, we have a 3. But you see, there's a 3-4. That immediately makes it higher than the 300. So really anything under 300 is going to go in this box. And anything over 301 is going to go in this box. And sure enough, 345, that's taller. So we put the name, it said, right? Blanca Peak. And then we come down to Crestone Peak and see there's a 2. So that's less than the 300 spot right there. So it lets us know it has to be in here. We have Humboldt Peak, a 0 in there. Okay, has to be, is less than 3. I know I'm kind of sloppy here. Mount Whitney, here we have a 4, so it's definitely greater than 3, so that's going to go right over here. University Peak, 4.7, that's up. I mean, I should say it's up above the 301. Now we have 246, that's under. Again, I'm just looking at that hundreds place. That 2 lets me know, it's below. So White Mountain is going to go here. So it looks like we have 3 on one side, 3 on the other side. Okay, now it says circle the name of the tallest peak. Explain how you know which of the mountain peaks is the tallest. I really don't even want to look. I know Mount Whitney is the tallest peak. It just is. And how do I know? So I'm going to say the reason I know is because of blaze value. How do I know? I know Mount Whitney is the tallest because I paired digits from the greatest place value to the least. Oh, look at this here. What do we have here? Look, it's the arrow again. Now, since Mr. Rodriguez bought 420 pencils for the school, if there are 10 pencils in a box, how many boxes did he buy? I see this problem being all about division. And the reason why I see this problem as division is because what I'm seeing is like this total amount, which was the 420 pencils listed right there, and there's 10 pencils in a box, like there's a group of 10 pencils. And why does that surprise me? Only because we were focusing on this particular chapter a lot about adding and subtracting whole numbers, so I didn't know they were going to get into division. But I think the reason why they put this problem in here is because we've got that wonderful power of 10. So rather than seeing this problem maybe as so much as division, I don't know, maybe you can see how the power of 10 is working out here. See, any number, if we had, I'll give you a, if we had 42 boxes of pencils, and then I told you there was 10 pencils in a box, you would know, oh, well, I need to take the number of boxes, okay, 42, and I need to multiply it by 10. Well, that would give me 420. So we just basically just did the inverse operation here. What we did is rather than thinking of the 420 divided by 10, we did 42, and I just picked that number randomly because, well, I knew the number that was the correct answer. But do you see the relation? This is what they want you to see. Here's 42, here's 420. What they want you to see is the 10. That 42 and 420 is a difference, by a power of 10, meaning 420 is 10 times greater. We know that because we multiplied 42 by 10. That would mean that 420 would have to be 10 times greater than 42. See, and you could keep going if you wanted to. You could just say, well, what's a number that's 10 times greater than 420? That number that's going to be 10 times greater is going to be a number that's times 10. But you see what's going to happen here? We don't really actually have to multiply. It's just going to be one more power of 10. 4,200. In the old math series, before Common Core, they used to call this patterns of multiplication. And that's really what it is. You can see the patterns, what starts to happen when you multiply by a 10. So when we come over here, how many boxes did he buy? Yeah, 42 is the correct answer here. And 42 is the correct answer simply because we showed all our work right here. Okay, it's all there. I hope that made sense to you. Again, like I said, you might have wanted to right away put that 420 and start doing this. There's nothing wrong with that. Did you see that operation? That's great that you saw that as division. And then you go, okay, it's going to go in there 4 times. Okay, and you're going to get 40, right? You're going to get 2 left over your 2, and it's going there twice. But then you should be kind of waking up to the reality that, oh, it's just a number that's 10 times greater. I'm just going to take that 10 off, and that by taking that 0, you've got 42. Just want you to see that. These concepts are important in math. All right, moving on, my friends. Here we are, last problem. Woo, this video is cruising by. It says Bobby and Cheryl each rounded 745,829 to the nearest 10,000. Bobby wrote 750,000 and Cheryl wrote 740,000. Who is correct? Explain the error that was made. Bobby and Cheryl, they rounded this number right here. Okay, just want to underline it. They rounded it to the nearest 10,000. This is crucial because this is going to decide who's correct and who made a mistake. Okay, so there's my 10,000. That's what we're rounding to. So when I take my number, 745,829, and I'm rounding to the nearest 10,000, that's what I need to do. See, I need to get that place right here, which happens to be the 4. When we're rounding to the nearest 10,000, basically what we're trying to determine is this number closer to 740,000? Remember this in that previous lesson. Or is it closer to 750,000? Well, that midway point, which I like to think of as like a benchmark number, is going to be 745,000. That's the number that's actually in the middle. It's right in the middle. So if the number is greater than the 745,000, we know it's going to be closer to 750,000. And of course, if it's less than, it'll be over on this side with the 740,000. So here's our number, 745,000. But look, there's this 829 on there. That automatically puts it more onto that side. So that would mean that in this case, Bobby, he wrote the 750,000. He would be correct. And Cheryl, the mistake that she made was she rounded down to 740,000, and I'm assuming, I don't know what Cheryl was thinking in her head, okay? But she rounded down. If you want to think of it, just the skill that we talked about in the previous video, the 4 or less, let it rest, 5 or more, up the score. Well, here's the 4. It turns to its neighbor, and you could say this may be the mistake that Cheryl made. There's a 5. Well, when we say 5 or more, we up the score. Even if you have exactly 745,000, we go up to 750,000. So her mistake is the digit maybe to the right of the 4 was a 5, so she should have rounded up. I don't know what else you could say. So I'm going to go ahead and put it here. Bobby was correct, and Cheryl didn't increase the digit 4 to a 5 in the 10,000s place. Or actually, it's just 10. Excuse me. Sloppy. Just going to cross it out rather than get my eraser. And maybe I should make a note that a digit of 5 or more, we up. That sounds kind of funny how I already use the word increase the digit, but yeah, we up the digit. Maybe not the best written. We up the digit by 1. Different ways you can say that. Okay? I'm just kind of going crazy. Hey! Whoa, I can't believe it's the end of the video. Woohoo! Yeah. Oh, whatever happened to our shark friend? We need to get his name. Oh my goodness, that fearful, like tired shark. Whew. He looked kind of scary, huh? He looked like he's having a hard time. I don't know. I hope he's good. I hope everything's all right with this. You know, in our videos, we care about our animals. You know what I'm saying? So, hey, I hope he's good. And that, my friends,
Blue.